we are going to discuss class 10th, chapter 2, Polynomials. Already have learned this topic in class 9th. Polynomial. What is meant by polynomial? Definition of polynomial. An algebraic expression which has non-negative integral power. Non-negative integral power is called polynomial. Some examples. Ax squared plus bx plus c. This is one of the example. Here it has three terms. Each term power is non-negative integer, where a, b, c are real numbers. Another one example. Ax cube plus bx square plus cx plus d. This is also a polynomial which has a non-negative integer power, and you can see a, b, c, d are real numbers. The next one, how can identify a polynomial? Look at this. Here we need to identify whether it is a polynomial or not. How can I identify? Look at this question. Y square minus 2. Is it a polynomial? It is based on the definition. Already we discussed. In definition, I told you non-negative integral power. Look at this. Y square minus 2. The variable is y and the power of y is 2. We know 2 is what? Non-negative integer. Now we have a little confusion about non-negative integer. I'll clear that. Look at this. The number line. Can you see the number line here? Yeah. 0, 1, 2, 3, 4 on the right side and minus 1, minus 2, minus 3 on the left side. You know, either minus 1, minus 2, minus 3. These all are what? Negative integers. 1, 2, 3. That is what? Positive integers. Okay. So now non-negative integrals are 0, 1, 2, 3. That pack is non-negative integers. These all numbers are non-negative integers. Now is it clear? Now we can come back to our examples. Y square minus 2. Is it a polynomial? Yes, it is a polynomial. Now look at the second example. 3x square minus 2x plus 5. Is it a polynomial? Yes, it is a polynomial. It has three terms and each term you can see only the powers are what? Non-negative integers. So we can say it is a polynomial. Another one example. 3x square minus under root 5x plus 2. Is it a polynomial? Yes, it is also a polynomial. Variables powers are non-negative integers. Another one example. 3x square minus under root x plus 2. Is it a polynomial? It is not a polynomial. Why it is not a polynomial? Because under root x, yes, under root x we can rewrite as x raised to the power 1 upon 2. Under root x we can rewrite as x raised to the power 1 upon 2. The power 1 upon 2 is not a non-negative integer. It is a rational number. So we can say it is not a polynomial. Next, we can revise terms. What is meant by terms? It's very easy thing. Yeah, look at this example. 3x square minus 2x plus 1. How many terms are there? Yes, exactly. 3 terms are there. 3x square minus 2x plus 1. One more example. 3xy. Here how many terms are there? 3xy. How many terms are there? Only one term. Okay. Only one term. Y minus 2. How many terms are there? Now 2 terms are there. Y and minus 2. So what did you understand from this? So listen here. The terms are separated by plus or minus. Next, degree of polynomial. Highest power of a variable is called degree of polynomial. Okay. Look at this example. Just we can revise it. 3x square minus 2x plus 1. 3x square minus 2x plus 1. Here how many terms are there? 3 terms are there. We know the powers of each term. Okay. The first term power is or exponent is 2. The second term power is or exponent is 1. And we know constant power or exponent or degree is 0. So now the highest power is 2. So the degree of this polynomial is 2. Now we can learn types of polynomial. By 2 ways we can categorize polynomials. First, based on terms. Okay, based on terms. You know this already. You are learning class 8th and 9th. Okay, monomial, binomial, trinomial. Monomial. One example. Monomial. What is the name monomial? Single term. Okay, one term. Binomial. You know bicycle and all. Yes or no? Binomial, 2 terms. Trinomial. You know very well. Triangle and all. trinomial, 3 terms. Okay, some examples are there: monomial, binomial, and trinomial. Okay, next we can categorize the polynomial by using their degree. Okay, look at this: zero polynomial, constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial. Zero polynomial. Okay, zero polynomial. Zero is called zero polynomial, and degree of the zero polynomial is not defined. Next, constant polynomial. Constant polynomial. The zero degree polynomial is called constant polynomial. It can be any real number: 1 upon 2, 3, minus 3, 3.5, 2, 2 upon 3, 2 by 3. Next one, linear polynomial. What is my linear polynomial? Yeah, the polynomial of degree 1 is called linear polynomial. Look at this example: 3x, 3x. What is the degree of that polynomial? We know 1. X minus 2. What is the degree of that polynomial? 1. Y minus 3. What is the degree of that polynomial? 1. Okay, so these all are linear polynomial. Next, quadratic polynomial. The polynomial of degree 2 is called quadratic polynomial. Look at these examples: ax square minus bx plus c. Okay, here you can see degree is 2, so it is a quadratic polynomial. Another one example: 4x square. What is the degree of that polynomial? 2. So it is also an example of quadratic polynomial. The next one, cubic polynomial. Okay, polynomial of degree 3 is called the cubic polynomial. Look at these examples. Okay, you can see all the examples, degree is 3. So it is cubic polynomial. Next one, biquadratic polynomial. It is not mentioned in your textbook. Anyway, you keep in mind, biquadratic polynomial. What is biquadratic polynomial? The polynomial of degree 4. The polynomial of degree 4 is called biquadratic polynomial. Here are some examples of biquadratic polynomial. The next is value of polynomial. What is value of polynomial? How can I find the value of polynomial? Look at this. Here, p of x is any polynomial. Okay, p of x is one polynomial, and a be any real number. A be any real number. Then p of a is value of polynomial. P of a is value of polynomial. Is it clear? Okay, we can try with one example. P of x. P of x equal to 4x square minus 3x plus 1. It is a polynomial. Okay. And a, here instead of a, I am assuming the number 1. A can be any real number, already I told you. A equal to 1. Shall we substitute the value here? Okay. So p of x we are going to rewrite as p of 1. Okay. Then next what I need to write in the RHS side? Tell me. 4 of 1 square minus 3 of 1, or 3 into 1 plus 1. Okay. The next step, 4 minus 3, 1, 1 plus 1, 2. Now, p of 1, the value of that polynomial, p of 1 equal to 2. Okay. Is it clear? One more example. Okay. Instead of plus 1, if you substitute minus 1, then what will be the result? We can check it. Okay. P of minus 1 equal to 4 of minus 1 whole square minus 3 of minus 1 plus 1. Now we know minus 1 whole square is plus 1. So 4 into 1, 4 plus minus 3 of minus 1, it will be plus 3. 4 plus 3, 7, and 7 plus 1, 8. This is called value of polynomial. In this way we can find out the value of polynomial by using any real numbers. Okay. Next one, zeros of polynomial. Okay. Zeros of polynomial, or you can call it as solutions of polynomial or roots of polynomial. Okay, zeros of polynomial. It is just like a value of polynomial. P of x be any polynomial and a be any real number. If p of a equal to 0, okay, the value of polynomial is equal to 0, then that a is called zeros of that polynomial, or zero of that polynomial. Okay, we can see one example. Okay, p of x equal to x minus 2. Okay, in the place of x, I am replacing, okay, x by 2. So we can write p of 2 equal to 2 minus 2. Here I use the real number 2. 2 minus 2, which is equal to 0. While applying 2 in the place of x, the result is 0, then the 2 is called 0 of the polynomial or root of the polynomial or solution of that polynomial. Okay. These zeros of polynomial and the degree are connected. Okay. Linear polynomial degree is 1, then there will be only 1 0. Okay. Quadratic polynomial degree is 2, there will be 2 zeros. And cubic polynomial degree is 3, there will be 3 zeros, maximum 3 zeros. Sometimes it can be less than that. Next we are going to learn geometrical meaning of zeros of polynomial. Now the polynomial we can plot in a graph. Okay, graphical representation of a linear polynomial we can see. You can look at this. P of x equal to x minus 2. Now we can present this polynomial in a graph sheet. Okay, so P of x equal to x minus 2. Now I am considering x minus 2 equal to y. So y equal to x minus 2. We know how can find out the coordinates x and y. Okay, here I assumed x equal to 0, then y become minus 2, and here x equal to 2, then y become 0. Now we can plot this point in a graph. This is our graph. If you try to present linear polynomial in a graph sheet, there you will get a straight line. This x minus 2 straight line intersecting x-axis at one point. It is intersecting at 2. This 2 is 0 of the polynomial. 0 of the polynomial. Okay, you can draw any linear polynomial in a graph sheet. It will intersect at only one point. Okay, you can draw any linear polynomial on a graph sheet. You can draw any linear polynomial on a graph sheet. That line will intersect only one point in x-axis. Okay, because we know already linear polynomial has only 1 0. Next, geometrical representation of quadratic polynomial. It is a polynomial of degree 2, so there will be 2 zeros. Okay, this representation we will get a shape like this. This is called parabola. This parabola will cross or will touch or will pass through the x-axis maximum at 2 points. Okay, it can pass through at 2 points, and sometimes it will touch only 1 point, and sometimes it will not touch. Okay, these are the chances. Sometimes it has 2 zeros, 1 0, or no zeros. These are the situations. Next, geometrical representation of cubic polynomial. If you represent a cubic polynomial in a graph sheet, you will get a diagram in this way. Okay, here you can see these curves are passing through x-axis at 3 points. Okay, it can touch 3 points. Sometimes it will be less than that. The first diagram you can see the curve is passes through 3 points of x-axis. Next, it is passing through only 2 points. Another one, it is passing through only 1 point. Okay.
Now we can check what we have learned in the last class. Exercise number 2.1. Okay. The question number 1. First diagram. Can you see the first diagram? In this first diagram, the line which is not passing through x-axis, so it has no zero. In the second diagram, you can see the curve. It is passing x-axis through only 1 point, so it has only 1 0. The third diagram, the curve, it is passing x-axis through 3 points, so it has 3 zeros. Similarly, you can complete 4th, 5th and 6th. Thank you.